Hello, today we are going to talk about automatic temperature controller, which is our project. This was done by Aban, myself, Al Harith, Jamal and Ali Nasser. The purpose and benefits of the project. Our technology is designed to assist people. For example, if it's hot outdoors, the automatic temperature controller will assist in cooling, and if it's chilly outside, it will begin to heat up. Our project can also be applicable in vehicles for safety purposes. This will prevent any lethal incidents. How is it sustainable? For example, if the air conditioner is turned on and the owner forgets to turn it off, the automatic temperature controller will turn it off. This will save electricity and will be sustainable. The components used are DHT11, temperature and humidity sensor, jumper wires, breadboard, Arduino microcontroller, LCD display, potentiometers, DC fan and LEDs. The DHT11 sensor is a basic ultra-low-cost digital temperature and humidity sensor. It uses a capacitive humidity sensor and thermistor to measure the surrounding air and spits out a digital signal on a data pin. No analog input pins needed. It's fairly simple to use but requires careful timing to grab data. DHT sensor library is required. Jumper wires, jumper cable, dew point wire or cable is an electrical wire or group of them in a cable with a connector or a pin at each end or sometimes without them, simply tinned, which is normally used to interconnect the components of a breadboard or other prototype or test. Breadboard. A breadboard is used to build and test circuits quickly before finalizing any circuit design. The breadboard has many holes into which circuit components like ICs and resistors can be inserted. Arduino microcontroller. Arduino Uno is a microcontroller board based on the ATmega32-8P datasheet. It has 14 digital input-output pins, of which 6 can be used as PWM outputs, 6 analog inputs, a 16 MHz ceramic resonator, a USB connection, a power jack, an ICSP header and a reset button. Arduino Integrated Development Environment is required for programming. LCDs are commonly used for portable electronic games as viewfinders for digital cameras and camcorders, in video project systems for electronic billboards, as monitors for computers, and in flat panel televisions. Liquid crystal library is required. Potentiometer. A potentiometer is a 3 thermal resistor with a sliding or rotating contact that forms an adjustable voltage divider. Potentiometers are commonly used to control electrical devices such as volume controls and audio equipment. DC fan. The direct current fans or DC fans are powered with the potential of fixed values such as the voltage of a battery. In contrast, the alternating current fans or AC fans are powered with the changing voltage of positive and of equal negative value. In general, this changing voltage has sinusoidal shape. Light emitting diodes or LEDs and lamps produce light when a current flows through them in the forward direction. LEDs and lamps are often used for indicator lights in electrical equipment such as computers and television sets. As LEDs use a much smaller current than other types of lighting, their use is increasing. Now here's the programming. As you can see in this programming we used for our prototype, all the libraries are also shown. So we begin with void setup, LCD begin 16.2 pin mode fan output, and we also include DHT library and liquid crystal library. We also set the pins for each of the liquid crystal pin, and we name the DHT, and we define fan in pin 13 and define DHT11 in pin 8. And for the void loop we did digital reading with the sensor, and the cursor was set to 00. We printed temperature and displayed the temperature, and also we programmed that if the temperature is more than 20 degrees the fan should be high and the light should be low, and also if the otherwise the fan should be low and the light should be high, and then delay 1000 seconds. Circuit diagram. This is the sketch of our prototype. We made it on the Tinkercad website. It features all the parts we described. And this is the prototype in real life, an image. And for the Sustainable Development Goals, also known as SDGs, it's good health and well-being number 3, because this will also help the people from any incidents or accidents. Affordable and clean energy, because it's sustainable, it's affordable and clean energy. Responsible consumption and production, because of the programming it can be efficient and reduce the consumption and production. Okay, so here is our prototype. This is a smart and sustainable home that we created, so we've attached this here, our technology in here, ATC in here, and this can be integrated in a car or in a house or anywhere, so we've added this in a house. So this is the DHT11 sensor here, and here is the LEDs as heater, and there's the fan. That's the controller being powered by the solar panels. Okay, so now I have to heat this up. Now it's in a suitable temperature, that's why the fan and the light, both of them are off. Now I just have to heat this up to turn the fan on. Okay, looks like the fan is moving. Yeah, it's speeding up. Yes, so it's sped up. Yeah, so now I have to cool this down. Okay, now when it's too cold, the light turns on and the fan turns off, because the temperature is sensing a very low degree. Okay, so if it's in a suitable temperature, both the fan and the light will turn off. Okay, so this is our project, this is our house. Thank you.